Hi class, let's take a look at this example. Now they still want us to do the integration by parts. So this one, we could actually start by letting u equal to the tangent inverse. So u is equal to the tangent inverse of x. And then technically dv is equal to dx. Now the selection that I'm doing here, u is being the tangent inverse, that's because it has a easy derivative. So we're talking about the derivative of tangent inverse is technically 1 plus x squared, and in this case this is going to be dx, and v, it's simply going to be an x. So to evaluate this integral, we'll worry about the limits until the very end. So in this case, you're looking at, well, we could rewrite this one as the integral of the tangent inverse of x. We'll put the limits in a minute. With respect to x, it's equal to, and as we applied the actual formula, this is going to be an uv minus the integral of v du. And I'm saying I'll wait for the limits because we may have to go back and switch those. So we're looking at your u and the v. So for this one, our u was the tangent inverse, and so this one will be an x times the tangent inverse of x minus the integral of technically v du. So our v was an x, a du, it's gonna be technically the x over 1 plus x squared. So this is the part that we're looking at to see if it actually worked. Let me rewrite it. So in this case, we're talking about an x tangent inverse of x minus the integral of x over 1 plus x squared dx. And technically, we could plug in the limits. This is 0 to 1, and technically 0 to 1. And then here you have 0 to 1 for that portion to be evaluated. Now, we're technically not done. And here we have a minor problem. And that is to approach this portion of what's left behind as we're doing the v du, or the integral of v du. In this particular one, we could apply again by parts, but it's just actually easier to apply, well, the regular u substitution. So this will be by u substitution. So you could simply let, in this case, let u equal to 1 plus x squared. So du is equal to 2x dx, or technically du over 2x is equal to dx. So let's see if this is actually going to work. So let me rewrite it. In this case, we'll plug in the limits in a minute. So this is x tangent inverse of x of 0 to 1 minus, and technically we're gonna have the integral of x over u, and then technically this will be du over 2x. And what we're hoping to cancel with this is your actual value of the x's, so that we end up with, in this case, x tangent inverse of x. We'll plug in the limits of integration. minus, I'm just going to write it as 1/2 integral du over 2. And then for limits of integration, since the original integral went from 0 to 1, so let me just do the limits here. So for x is equal to 0, u is equal to 1, and x is equal to 1, u is equal to 2. And let me just double check. It went from 0 to 1. As we did the u substitution, if you plug it 0, that's 1, and then to 2. So technically, as we're doing the u sub, now it's going to go from 1 to 2. So this is from 1 to 2. The original limits went from 0 to 1 before the u substitution. So in this case, we're actually looking at this one being x tangent inverse of x from 0 to 1 minus 1/2. This is supposed to be a u here. So technically ln of u evaluated from 1 to 2. So let me just wait here a minute because we're just evaluating. Make sure that you're actually, well, in this case, adjusting the limits of integration for the u. Or you could go back and put in 1 plus x squared and keep the original limits. Okay, so let me plug in the limits and simplify our answer. So as we plug in the first one, you're just going to get 1 tangent inverse of 1. The second portion minus 0, it's going to cancel out. So this is the first portion. Let me rewrite it. So the first portion, it's going to be 1 tangent inverse of 1 minus 0. And then technically minus 1/2 ln of 2 minus the ln of 1. Ln of 1 is 0, so technically this term is going to go to 0. And the tangent inverse of 1, that's actually a special number. That's going to be pi over 4. So please check it. It's actually pi over 4. So for this one, you're going to get pi over 4. Technically minus 1/2 ln of 2, which it's an actual exact answer. And then let me give you a decimal approximation. Okay, I'm getting that this is approximately 0.43. I'll just keep it as 88 as our decimal approximation for this one. Okay, kind of messy, but you happen to have, well, the limits to evaluate, and then as a result of the by parts, we end up with a possible u substitution. Back here where we did the u substitution, we could have tried by parts again, but it was getting already too long.